Coming to unit 1, let's start with by defining random variable. In a sample space, we know already that it is set of all the possible outputs of a random experiment. Now, when any output or group of outputs is given by a function in terms of function, then it is a random variable. It is denoted by capital X as well as X, Y, etc. Now we know in a function f or in a function g or whatever it is, it has a domain and it has range. Domain is the one such as earlier classes you might have learned g of x equal to some x square plus 2x plus something, some function. Now whatever values this x can take is domain. Accordingly, whatever result we will get by substituting that x value in the given function is range. Now, if x is a random variable output of a sample space and one of the outputs of a sample space, this sample space is nothing but the domain of the random variable. And when we substitute this value in the function, we will get a range, which we will study in terms of p of x or f of x, which is called probability function. That is called range of the random variables. Depending on plot of random variable and probability function, when we plot them on a graph, we will, depending on what type of values this random variable takes, either discrete means 1, 2, 3 like that, countable form, it is discrete. When it is not countable, it is continuous. In between values also, if we are giving an interval, if in between values also it is able to take, such as if 1 and 2, if we are saying, then again in that 1.1, 1.2 also it is able to take, then that is a continuous one, continuous variate. So depending on what type of values random variable can take, that is again classified as discrete variate and continuous variate. Now, as we have discussed, x can be a discrete variate or a continuous variate depending on what type of values, that is countable values or uncountable values, or finite or infinite values that it takes. Now coming to discrete probability distribution, if this x equal to discrete variate is a discrete variate, and this discrete variate is nothing but, as we discussed, domain is sample space, that is, it is an outcome of some experiment, any outcome we can, then probability that this value of this x will be some xi is denoted by pi, or p equal to p means probability of x such that x takes value xi, x equal to xi. Then that is probability such as, say, let x equal to 1 imply, then probability that in a question he has given x is some outcome, if that outcome value has to be 1, then probability that its value 1 is denoted by p of x equal to 1, like that. That is an example. Now this p function is nothing but probability mass function. For discrete case, this function will be probability mass function. Now, this value of I can be 1, 2, 3, anything. Which value this x takes, xi value, x1, x2, x3, whatever value is taking, that I is 1, 2, 3. Okay. Now, if this is the case, we already studied that probability can never be less than 1. Least value is 0 and maximum value is 1. So, probability mass function value is always greater than or equal to 0. It cannot be negative. And we already studied that for a sample space, if we include all the output values, probability of occurring all the output values is 1. This is nothing but that case. If we sum up all the values or all the outcome probabilities for all the outcome values of the sample space x1, x2, x3, where I equal to 1 to n. If n outcomes are there, for each outcome, if we add the probability, then total probability will be 1, as we already discussed in the previous class. Now, coming to cumulative distribution, or simply distribution function, which is denoted by f of x. This f of x, small x, is nothing but probability that random variable x takes values up to, not equal to, up to the small x. It means that from x1 to x2, x3, x4 up to x, this all probabilities, when we sum up, this total is nothing but cumulative. In cumulation, what is mean by cumulation? We will add first value to second, then total value to third, then this total value to fourth, like that we will add up. So we will get the sum of all these things. So in the same way, from first to some xr. If you say to avoid confusions, let's, instead of saying small x, we will say xr. Up to xr value, we will add all these probabilities, then we will get cumulative distribution. This is nothing but summation of all the probabilities from first random variable first value to random variable rth value, p of x equal to xi. This I will be from 1 to r, 1, 2, 3, 4. So summation of p of x1, p of x2, p of x3, all things will give you p of f of xr, cumulative distribution function. Okay. Now coming to continuous probability distribution, then x be a continuous variate. Continuous variate in the sense, if we are given certain interval a comma b, it takes every value in that interval. That is continuous variate. If such is the case, then probability that x takes a certain value small x in the given interval, then the probability of x to take this x is given by f of x. This is a small x, this is capital X. You have to understand the difference. This is a variable, this is certain value which we expect x to take. So f of x. This is, earlier we have told pi. Now here we have the f of x. This f of x, here pi, in the earlier case, discrete case, I have mentioned pi directly. Because in that, for a particular value of x, there exists particular value of probability directly. Here, it is in case of continuous, if this is random variable x, then this will be a probability function. This is probability density function. Probability density function. Now, probability that x takes this small value x is given by f of x. Okay. Now this is probability density function. When we plot this f of x against random variable x, for each, say it is defined in the interval a comma b. Then this interval given is a comma b. Within this interval, for each value of random variable, we get certain value of f of x. Example, let's say this is the curve we got. So in the interval, it is defined as like this. Okay. So this is the curve f of x. And this is a continuous curve between a and b. This is about continuous probability distribution. Now coming to earlier case like cumulative distribution function, f of x. In this case also, f of x is p of x less than or equal to x only. But earlier case, it was discrete, so sigma, summation. Here it is continuous, a curve. So it is integral. From where to where? From minus infinity, because here this f of x value can take from minus infinity less than or equal to x less than or equal to infinity. So in this interval, anywhere this f of x can lie, or x can lie, x can lie. In that, we may define, here in this example I have told that x is defined in this a and b only. Sometimes it may be defined in negative values of x also. But f of x will be on positive side because it is a probability, it is denoting probability, it will be on positive side. But an x-axis, this random variable can take any negative value or positive value. So, cumulative distribution function, there in discrete case we have made summation. Here that is countable to summation. Here it is not countable, it is uncountable, like heights, masses, like that. So it takes continuous values, so only option is to integrate. So generally this will give minus infinity, least value to maximum value is giving up to x, accumulation is up to x only. So upper value limit is x, f of x dx. So this is given by cumulative distribution function. Remember, in the discrete case, that p of x equal to xi is probability mass function. Here in continuous case, this f of x is probability density function. There it is mass, here it is density. Okay, few more things that as probability density function, this is f of x is regarding probability, f of x is always greater than or equal to 0. Okay, that is number 1. Number 2, x is defined in minus infinity to plus infinity. So total probability is together summation. In discrete case, continuous case, integration. It is the same. If in discrete case summation and in continuous case integration, both are same. So up to plus infinity, because its range is minus infinity to plus infinity, f of x, if this is total f of x dx, this is the total probability of x taking different values between minus infinity to plus infinity equal to 1. In the discrete case, sigma equal to p of x equal to xi, that is equal to 1 we have written. Similarly here also, we have to observe that f of x is nothing but integration of f of x. So when differentiate f dash x, we will again get f of x. But this f of x is nothing but greater than or equal to 0 at all cases. Implies if this f dash x is nothing but if f dash x is some function of x, it is a curve, then f dash x, if this is f of x, this f dash x is nothing but a slope. At certain point, if you take this is x, at this point x, if this is f of x, capital F of x, then its slope at this point is nothing but f dash x. It is given that f dash x is f of x. From here we get f dash x equal to f of x. And from here we get f of x is greater than or equal to 0 for all cases. Finally, from this we can conclude that this f dash x is greater than or equal to 0 for all cases. From calculus part, we can understand that for any function, if we differentiate and the first differentiation is greater than 0, then this curve f of x is always an increasing function. It's now from this side you have to understand that f of x is this. If f of minus infinity is there, equal to minus infinity to minus infinity, so there is no limit. Limit is 0. Dx will be 0 because summation at starting point, this is nothing but if minus infinity to plus infinity, if we extend this other side, this is minus infinity. From minus infinity to say this is x, so this f of x curve is something like this. So this capital F of x curve is nothing but area under this curve between those limits. Now when f of small x is there from minus infinity to this x point, this total area between these lines is f of x. Similarly, f of minus infinity means here starting point is minus infinity every time and ending point is also minus infinity. So here this is a line. So line don't have any area. So f of minus infinity is 0. Now f of plus infinity, when you come, it is minus infinity to plus infinity f of x dx, which is nothing but from here we can understand this total area. So plus infinity up to plus infinity. So this is the total f of x curve. Total curve area will be always 1. This is basic thing from probability point of view. Probability of total sample set will always be 1. That is our earlier discussion. So from there we are getting this point. From here we are correlating this here. So f of plus infinity will give you this one, but this is nothing but equal to 1. So f of plus infinity is 1. F of minus infinity is 0. This is two things to remember. Now from all these discussions, one thing we can definitely tell that between 2 points, if we want probability of x taking those values, what I mean to say is, suppose at x is there, we want this x random variable to take values between a and b. This probability that x takes these values only is given by this curve between these things. So what is the thing we will see? P of a less than or equal to x less than or equal to b. Which, how we will get this, we will tell you. First of all, tell me what is f of b. F of b is minus infinity to b f of x dx. Which from calculus part, from this we understand that from minus infinity area, somewhere on the x-axis we will get minus infinity. We don't know where it is because minus infinity we cannot directly tell here it is. But for understanding purpose, I am telling from side. In minus infinity is this side. If it is 0 in x-axis, so this minus infinity f to b up to here. This total area is nothing but this minus infinity of this thing. So this is a cumulative probability of x taking values from minus infinity to b. Now f of a is equal to minus infinity a f of x dx. Okay, so now this f of a is nothing but from say minus infinity only up to a we want area, this part. So value of random variable, probability that the random variable takes values between minus infinity to a is given by this. So this is nothing but the area under this f of x curve, small f of x curve between minus infinity to a. This is nothing but this area part I am telling is from calculus part. So in calculus says that if something is like this, then area under this function between these limits minus infinity to a is nothing but this total function. Okay, now this upper part is this total up to b. This lower one is up to a. From upper part, if we do minus negative f of b minus f of a, if we do it, then what we will get is from this total area, we will remove this area. So what we will get from, so this remaining is this area. So this area is nothing but probability that random variable takes the values between a to b, which is our requirement. So we can say that p of a less than or equal to x less than or equals to b is nothing but f of b minus f of a. So this is clear to you all. Now let us see an example. This is this example for discrete distribution. A random variable x has probability function. I mean the relation between x and its probability function is given like this. That is asking us to find the probability, this value of k given in this and evaluate probability of x less than 6. This means that we have already known cumulative probability up to 6 or up to value less than 6. Less than 6 is 5. Means up to 5 we have to calculate. We have to sum up. That is nothing but f of 5, because less than 6 is given. Before 6 only 5 is there. Up to 5 we have to take f of 5. Okay, so let's find first one. We already know from the earlier discussion that sigma I equal to 1 to n. Here 1 is first value x, first 1 is x1. x1, this is x1, x2, x3, x4, x5, x6, x7, x8. So total 8 values are there. 1, 2, 3, total 8 values are there. x1 to n p of xi equal to 1. We already know it. Implies p of x1. x1 is 0. x1, I am not telling 1. I am telling x1. x1 value is 0. x2 is 1. x3 is 2. So, summation of all these probabilities must be 1. So, 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k equal to 1, which implies if you say k square, this is 1k square, this is 2k square, this is 7k square, total 10k square plus 1 2 plus 2 3 plus 2 5 plus 3 8 plus 1 9k. Okay, so 1 we will take this side, so minus 1 equal to 0. Okay, so this one we can factorize like this: 10k square plus 10k minus k. 9k we can write like this: 10k minus k minus 1 equal to 0, which implies 10k of k plus 1. From this both the values we take 10k as common, then k plus 1 is remaining. Minus we take common, then again k plus 1 is remaining, equal to 0. From the total 10k minus 1 into k plus 1 equal to 0. Now from this we get 10k minus 1 equal to 0, which implies k equal to 1 by 10, and k plus 1 equal to 0, which implies k equal to minus 1. So but k value, if it is minus 1, I have already told that any pi value, that is p of x equal to xi value, must be greater than 0 or equal to 0. But if k is negative value, we see that here these values will be negative, which is not agreeing with our earlier discussion. So this cannot be the value. So remaining is this one. So k value is 1 by 10. Okay, the first part is evaluated. Now let us come to second part. Second part is he is asking us to evaluate up to 5. So second part, what is that? F of 5, that means p of x less than 6 equal to f of 5 equal to sigma I equal to 1 to n, up to not up to n, up to 5 only, because we need up to 5 only. P of x equal to xi, which is equal to probability up to 5, first one to fifth one. So 0 plus k plus 2k plus 2k plus 3k plus k square. So we have sum up all these, we get 5k plus 3k, 5 plus 3, 8k plus k square. But we know k value is 1 by 10. So this is 8 by 10 plus 1 by k square, so 1 by 10 square, by, since k equal to 1 by 10, so which is equals to, we will multiply 10 upside and downside, so 80 divided by 100 plus 1 by 10 square means 1 by 100, which is equal to, denominator is same, so upside addition directly, 81 divided by 100. So this is the answer. Hope this is clear for all of you. Now coming to the next example, from the question is, if a random variable has a probability density, here he has given the word density. From this we can understand that it is example for continuous variables, continuous variate or continuous random variable. Even if you don't give the density value, he has given that f of x, he has defined some function in terms of x, and again he has given interval, x greater than 0 means 0 to infinity, that is an interval. So from when interval is given like this, and it is a function of x means in every value of between 0 to infinity, this can be defined. It means that x is defined for every value between this, in this interval, means that it is a continuous function. So continuous function is continuous random variable example. Now in this he has asked to find the probabilities that will take the values between 1 and 3. Means this x value should take values between 1 and 3. That probability we have to find. So if that is the case, it will, first one, p of 1 less than or equal to x less than or equal to 3. From that we can tell, earlier we have understood, p of a less than equal to x less than equal to b is f of b minus f of a. This is b, this is a. So f of 3 minus f of 1. Another way we can write this is, actually this is minus infinity to 3 f of x dx minus integral minus infinity to 1 f of x dx, which is equal to, from calculus this is very clear. If this is like this, then it is 1 to 3 f of x dx. So ultimately if we find this, we can find answer for first one. Now in 1 to 3 we have to check whether the function is defined or not. X greater than 0 everywhere it is 2 or 2 into e power minus 2x. So it is defined with a single function. So we can directly write integral 1 to 3 2 into e power minus 2x dx. Okay. So when we integrate it, we will get, if we integrate 2 into e power minus 2x, we will get e power minus 2x. Here 2 is there, 2 here by minus 2, everything will get cancelled. So it will be minus e power minus 2x will be the answer. Now 1 to 3, which means minus e power minus 2 into 3 is minus 6. Minus of minus e power minus 2, which is equal to e power minus 2 minus e power minus 6. From calculators, we can find that this value is 0.133. Hope it is clear. Now coming to the second part of the question, he has asked that probability of x taking the values greater than 0.5. So p of x greater than or equal to, or greater than 0.5. This will be given greater than 0.5 means lower limit will be 0.5, which belongs to always greater than 0.5 up to plus infinity. F of x dx, which is again equal to 0.5 plus infinity 2 into e power minus 2x dx, which is equal to minus e power minus 2x 0.52 plus infinity, which is equal to e power minus 1 minus e power minus 2 into infinity, which is infinity, which is equal to 1 by e minus 1 by e power infinity, e power 1 by e power infinity. Okay, e power infinity is nothing but infinity. So 1 by some infinity is 0. So this one becomes 0. So this is remaining. So which is equal to, answer is 1 by e. Okay. So 1 by e means this probability that the random variable x takes values greater than 0.5 is 1 by e. This value of 1 by e, from the calculator you can count and calculate it, that value of e is 0.368. Okay, so this is clear for all of you. Now coming to the next topic, it is expectation. A commonly mean mu of the probability distribution, maybe a discrete probability distribution or continuous probability distribution. Its mean is nothing but generally expectation, which is represented by E of x. It is another term given to it is first moment about origin for this mu. Mean mu, another definition is first moment about origin, first moment of this probability distribution about origin or center of gravity. In intermediate or plus 1 plus 2, you might have studied that if this is some area, for this you want centroid, this is coordinate axis x and y, then how will you find x bar? These are 2-3 areas totally to consider together as one area, single area. How will you take find centroid or x coordinate of the centroid of this total area? You will make area 1 x1 plus area 2 x2 plus area 3 x3 so on by total area. This x1 x2 x3 nothing but centroid of that particular area. Area a1 a2 a3 nothing but areas of that particular area. So this, and this total area means total this one. If you write it separately, this x bar can also be written as a1 by total area into x1 plus area 2 by total area into x2 plus so on. This area 1 into total area a2 is nothing but some weightage given to x1. Similarly, this is weightage given to x2. So this another way we can write is this x bar is nothing but summation I equal to 1 to n. How many, whatever n areas? This is 3 areas. In some other cases we can have n areas. 1 to n summation for each area, its weightage into its centroid or center of gravity gives you total overall center of gravity of the total area. The weightage is nothing but that particular area divided by total area. Okay. Similar way, mean of this probability distribution, in this weightage will be replaced by probability function. So E of x equal to mu equal to If it is a discrete, it is summation. If it is continuous, it is integration. So let us take discrete case. Then it is I equals to 1 to n like this into xi into weightage replaced by probability of that particular value. So this is discrete case. If it is continuous case, it is integration from minus infinity to plus infinity, because x is defined from minus infinity to plus infinity. Discrete case, x is given for first x1 value to xn values. So here x into f of x dx. Similar weightage is replaced by its probability function. In case of continuous, it is probability density function. In case of discrete, it is probability mass function into its actual coordinate x. So within its limits, minus infinity plus infinity for continuous, 1 to n for discrete. Okay, hope the concept is clear for you all. If instead of x he has given some another function in x, then everything will be same except in place of this x we will place g of x. If it is discrete, then it will be equal to 1 to n g of x into p of x equal to xi. It is discrete case. If it is discrete one, that distribution is a discrete random variable distribution, or equal to minus infinity to plus infinity g of x into f of x dx. In case it is a continuous random variable or continuous probability distribution. Till now, we have discussed about moment, about origin. If he is asking about moment, about mean, then it is nothing but instead of x, we will write x minus mu. Okay, instead of x, wherever x we are writing there, instead of x we will write x minus mu. It is first moment. If it is second moment about mean, we have in intermediate plus 1, plus 2 level we have read. First moment is integral x dA. Second moment is integral x square dA. Similarly, here also, second moment, but it is about mean. So instead of x we have to write x minus mu. So we will use x minus mu square. It is not, second moment is not x minus mu square. We will use x minus mu square in second moment. How we will use that I will tell you. Second moment variance is a concept which will appreciate us or give us a proper identification to observe how far the x values are deviating from the mean value. That intensity is specified by variance. Variance is nothing but second moment about mean. So it is noted by sigma square, where sigma is standard deviation. Now this is sigma square. It is sigma is standard deviation, sigma square is variance. Sigma square is given by, if it is a discrete case, I equal to 1 to n, I said instead of x square, is about mean. So x minus mu, second moment, not first one, second moment is square we have to apply, into that probability density, its weightage, p of x equal to xi, is xi, I equal to 1 to n. It is discrete case. Now if it is a continuous case, then it is minus infinity to plus infinity x minus mu whole square into f of x dx. It is a continuous case. Okay. Similarly, if it is, he is asking rth moment. Rth moment, then rth moment about mean will be, simply we will replace it by r. Simply will replace it by r, power r. Okay. Now next one is mean deviation about mean. Mean deviation about mean is nothing but first moment about mean, which implies this mean deviation about mean is, if it is a discrete case, it is sigma mod of xi minus mu into p of x equal to xi. If it is a continuous case, continuous random variable case, this is integral minus infinity to plus infinity x minus mu in mod into f of x dx. It is discrete, for continuous. Now let us see an example. He has given a probability distribution for variate x, which is taking values minus 3, 6 and 9. Probability that x takes value minus 3 is 1 by 6, it takes value 6 is 1 by 2, for value 9 is 1 by 3. Now he is asking us to take mean, first moment about origin and e of x square, second moment about origin, not mean, about origin. Now for first one, e of x, you already know it is a discrete value because x is taking countable form, not a continuously in an interval. So it is sigma case, summation I equal to 1 to n. This is x1, x2, x3. So it is n will be up to 3 only. And this is xi into p of x equal to xi. So which is equal to xi means minus 3 into its probability 1 by 6 plus when x is 6, its probability is 1 by 2 plus x is 9, then its probability is 1 by 3. So this will be minus 1 by 2 plus 3 which is equal to 6 minus 0.5 which is equal to 5.5. Hope it is clear for all of you. Or this we can also write it as 11 by 2. Okay. Now coming to the second one, he has asked us e of x square. When it is e of x square, we know that we have to make x square into the probability will be there. So x square minus 3 square into its probability 1 by 6 plus 6 square its probability 1 by 2 plus 9 square, its probability 1 by 3. When we calculate all this, we will get 93 divided by 2. Hope it is clear for all of you. Now coming to the next concept, moment generating function. For as far as discrete variables are concerned, moment generating function about x equal to a is nothing but expected value of e power xi minus a power t. If moment generating function about x equal to 0, then e power xi minus 0 into t, that way. Now what is implies it is denoted by moment generating function about x equal to a is denoted by capital M A of t equal to expected value of e power xi minus a into t, which is nothing but, as it is a discrete case, it will be I equal to 1 to n e power xi minus a into t into p of xi. I am writing in short, instead of p of x equal to xi, I am writing p of xi. So don't confuse. Okay. So this is how it is. Instead of I equal to 1 to n every time, I will write I. You understand from that. Now this one again, from intermediate, we will know that expansion of e power x is 1 plus x by 1 factorial plus x square by 2 factorial plus so on. Okay, so we have to collect that formula from intermediate level. Similarly, from that here, its expansion will be this p of xi, we will write forward into expand e power xi minus a. So instead of x, we are having this term. So we will write it as 1 plus xi minus a into t by 1 factorial plus xi minus a into t whole square by 2 factorial plus so on up to n, up to infinity, up to infinity. Now from that again we will get it as sigma I, we will multiply, we will disintegrate total thing, p of xi plus sigma I p of xi into xi minus a into t plus sigma I p of xi into xi minus a whole square into t square by 2 plus so on. This again we can write it as, this is nothing but 1 plus this is nothing but, t is a constant, we can take it outside, up to this part it is nothing but moment of the probability distribution about a, first moment. So this t into first moment mu a plus t square by 2 is again a constant into this part is nothing but second moment about a, not mu a square, it is second moment. Similarly up to so on. Hope this concept is clear for you all. Or else to avoid confusion, instead of upside I will write it downside only. Second moment about a, first moment about a. This is nothing but expected value of x minus a or xi minus a. Okay. first moment, second moment square, third moment cube, like that. So MA of t we are getting in some function of t. Okay, so that is the answer. Now this is all for discrete variable. If it was a continuous variable, then same moment generating function, instead of this sigma we will write integral and last we will add dx. That I will write it. We will write it as integral minus infinity plus infinity e power t of x minus a into f of x dx. Rest of the things we know. So this we have to remember. Okay. Hope the total concept is clear for you all.